LangChain just released its first major version, LangChain 1.0. A few changes or minor syntax tweaks, but there are several exciting additions. First, the prompt parameter in create agent has been renamed to system prompt. New as well is the context object. Instead of passing a plain dictionary as config, you now have a context class to supply runtime arguments. Using a data class instead of a dictionary makes this cleaner and more convenient. Dynamic prompting is also a new feature. This allows you to switch prompts by changing runtime arguments. Just import the dynamic prompt decorator and write a function with a single model request parameter. This gives you access to runtime parameters you can use to select different prompts on the fly. Version 1.0 also introduces middleware, which lets you run logic before and after the model call. For example, you can import a summarization middleware that runs before the request, or a human-in-the-loop middleware that lets users review LLM outputs. Another addition is the agent state class, a small helper that provides state keys like messages, which automatically collects all messages in a list, and jump to, which lets you execute a specific node deterministically. Here is how it works combined with a custom middleware. In this call counter middleware, you can implement two hooks, before and after model. You can define the schema as a class variable on middleware and access keys via get. This works because under the hood, it's a typed dictionary. A major change is also the agent's output structure. Previously, you only had a content attribute. Now there's a more flexible content blocks attribute. Since many new models are reasoning models, you can now access reasoning tokens by checking the type field for reasoning or text. If you used the class-based high-level components of LangChain, don't worry. They were deprecated and removed from the core package, but you still can use them via installing the LangChain Classic package and import from there. That's the main news. If you want a deeper explanation, stick around with me for the deep dive. Okay, we're now in VS Code and we are now making the deep dive into the changes from the 0.x versions to the new major version in LangChain. So we start with a few dummy tools that we're going to use throughout this notebook. We're also going to set a default model and a premium model. So nothing very special going on here. This is just for demonstration purposes. So first we start with agent imports, and we've got this create react agent function, which is often used for demo applications. This was before in LangGraph pre-built, so in the LangGraph package, and that moved into the LangChain package. So LangChain has got this agents module where you can now import the create agent function. So also a little bit a syntactic difference. Another rather small change was the change of the system prompt parameter. Before it was just a prompt parameter. Now the new function has got the system prompt parameter, which makes sense because in this prompt you define the agent's behavior, which is the system prompt. Next is a little bit more of a change. That is the context object. So before, when you wanted to provide runtime parameters, so behavior that should change each graph run, something like a username or user ID, you had to provide it like this. So the argument was config, which was a dictionary and had got this configurable key with user ID and then the value. So here you could provide endless parameters, whatever you want. So this is not so readable, and the new context object allows it to define it like this. So you import from data class, and by this you create a new data class, and this data class has got a single attribute, which is user ID. And now instead of providing this config dictionary, you just set context equals this context class with the dynamic value that you want to pass. The next one is dynamic prompts. So dynamic prompts are really useful if you want to provide different prompts for different runtime values. So like before, for the context object, you provide a dynamic prompt to change the behavior of an agent at the runtime. So how does this work in combination? We again create this data class with a single attribute user role and a second function where we set the dynamic prompt decorator. And now in this function, we set a single parameter, which is model request. In this model request, we get access to the context object by accessing the runtime attribute, and from there we access the context attribute. And in this context attribute, which is this context class, we can access the user role attribute. So this will give us the role. And now we can just make an if case. If role is equals expert, then it will be you are a deep technical assistant, and otherwise it will be explain concepts in plain language. Now we're gonna use it, and we're gonna use it in middleware. We will deep dive that in a few seconds, but in this case, you just provide the middleware like this, middleware equals, and then you can provide a list of middlewares, and you just pass the dynamic prompt as middleware. And now we're gonna use it like this, context, and then the user role is expert. Then we will use this prompt. Otherwise, we will use that prompt. Okay, so now let's make a deep dive into middleware. So this was only a very simple use case, and we can use middleware before and after a model run. So to make use of custom code before a model run, before that, you had to do it like this. So you created a function, and here in the create React agent function, you had to pass it here as pre-model hook attribute and set it like this. After that, so the new way where we use the create agent function from LangChain.agents is the following. So we use that function, and in here we pass a list of middlewares. So LangChain provides us a list of different middlewares. For example, before the model, we can use a summarization middleware, which takes all of the messages that we pass here and will create a summary, so we don't exceed the context window of this model. We can also have the case that we want to run something after the model was called. So this might be a human review hook. So in this case, this is just a dummy function, and we have to provide it here, the post model hook attribute in the create React agent function. The new way is again middleware. In this case, we can also import this pre-built middleware from LangChain, and here we can use it like this. Again, we pass it in this list object, and human middleware is used like this. So we have to provide an interrupt on, and here we want to provide the tools. So we've got for this agent, we've got this assistant tools where we've got one send email tool, and we want to interrupt on that. And the allowed decisions are approve or reject. So we can approve that, and then everything will continue. So the agent is allowed to send this email. Otherwise, the agent is not allowed to send this email. I guess in this case, it makes sense to show you the output directly. So we're going to use the invoke function where we pass a list of messages. So this message is what is the weather in Berlin. So it is not related to send email. So the agent will not use this human in the loop middleware. Okay, so now we get this value error, and I guess we can fix it by just removing here this check pointer. Okay, now it works. We can see that the agent is answering. The weather in Berlin is a temperature of 17 degrees Fahrenheit. Next message is related to an email. So now we're gonna ask, send an email with hi to my boss. And here you can see, now we interrupt. So we are now in the human in the loop mode, and we have to accept or reject that request from the agent. If you are interested in a deep dive into human in the loop, then you can watch one of my videos about this. You will find this in the description. Okay, let's now move on to custom state with agent state. So every graph has got a state object where you can read from and write to. You can do that with a type dictionary or with a data class. So in this case, we've got a agent state that we define ourselves with a custom attribute user name. So we define it like this. And now we've got a second way. We can import the agent state class, and again we can define our custom attribute, and very important, we have to inherit from that custom state. So where is the difference? The agent state looks like this. So we get this for free, messages. So this will help you to create a history. So if you send a message to the model, it will store the user message, then the I message, the user message, and the I message. So you get a nice chat history. The next one is jump to, and this allows you that you define deterministically to which node you want to so-called jump in a run. I'm going to show you that, how that looks like. So we do that in this custom middleware. This is also another concept, and we will directly integrate this with this agent state. So here we inherit from the agent middleware, and now we define this class variable state schema where we provide custom state. Here we provide one extra variable, model call count. And what we're going to do is we define one hook before model. So this is a middleware that runs before the model is called, and after model. This runs after the model is called. And the interesting part is this. So we gonna access the state model count key. So this is still a dictionary. So we can access it with the get method. And now we're gonna check if the count is bigger than 10. Then we will jump to end. And end is the end node of a graph. So this will directly finish the run. Otherwise, we will just continue. So this is what you get for free when you use the agent state. Okay, so the next concept that we're gonna have a look at is dynamic model selection. So you can also use middleware for this. In this case, we're gonna inherit from the agent middleware, and we're gonna use the rep model call hook for that. So we need two parameters, request, which is the model request, and we need this handler. This is the model request handler. As you can see, this is grayed out. It is likely wrong in the documentation, but this currently does not work. I hope this will work in the future, then I will update this notebook. But just concept-wise, it works like this. So we provide a middleware with this hook, and we're gonna pass that dynamically here. So now what happens is if the message, or better said, the history is longer than 10, then we're gonna use the premium model, otherwise we're gonna use the default model. And here we save that in this next model variable. So we can replace this model on the fly like this. So this is how it should at least work in the future. Okay, next concept is structured output, which is not new per se, but we've got two different output modes. So we've got a tool strategy and we've got a provider strategy. So the difference is that the tool strategy uses artificial tool calling to generate structured output. This works with any model that supports tool calling. A more sophisticated way is the provider strategy that uses the model's provider's native structured output generation. So OpenAI, for example, provides native structured output, but not every model does. So I recommend using the provider strategy for, let's say, OpenAI, and for other model providers, you can use the tool strategy, but it totally depends if your provider allows for structured output. Okay, let's have a look at another new feature, and that is standard content blocks. So before, when you, let's say, for example, asked what is the capital of France, then you got this content attribute. So the capital of France is Paris. So that is the answer from the LLM. But normally the new models, let's say most GPT-5 models are reasoning models, do not just provide the final answer, but also the reasoning tokens, and you are often interested in that reasoning tokens. So we've got a new attribute, which is content blocks. And this content blocks attribute is a dictionary. Here you can check for the type. If it is reasoning, then you can access this with the reasoning key. If it's text, then access it like this. So you get the following. Okay, in this case, we used GPT-4, so we don't have any reasoning tokens. But if you use the reasoning model, then you would also see the reasoning tokens. Maybe a little bit of a bad example here. Last but not least, we've got the legacy package where LangChain now collects every high-level chain that were the very first chains that they used. So let's say the LLM chain, where you can provide a model and also a prompt directly class-based. So the new way of creating workflows is graph-based, and I would highly recommend it. But if you still like these high-level chains, class-based, then you can still use it. But in this case, you cannot import it like this. So this is the old way to import it. You already saw a deprecation warning like for 1 year. Now it does not work. We've got import errors. But now if you install the LangChain classic package, then you can import it like before. So this is how it works. And you can use your LLM chain like before. Okay, that's it. I guess that was everything that is new in the major version in LangChain 1.0. So if you liked that video, please subscribe to my channel, give it a like, and I will see you in the next video. Bye bye.